I'm Derek McGowan. This is Mike Brown. We're maintainers on Containerd. We're going to give an introduction to Containerd today. We're going to talk a little bit about the history of Containerd. We're going to talk about the high-level architecture of Containerd, as well as the CRI for using Containerd and Kubernetes. Tomorrow at 3 p.m., we're having a deep dive session, which will go further into the different components of Containerd, as well as the plugin model that we use. So Containerd started in 2016. It was integrated into Docker 1.11. It was designed with a very simple goal to allow Docker to be able to restart without bringing down all of your containers. So it was a simple manager on top of run C. In later 2016, the Container Runtime Interface was designed. The Container Runtime Interface was built by the Kubernetes team in order to allow for the runtime of Kubernetes to be configurable. So previously, everybody was using Docker for Kubernetes, and it was very difficult to swap out to use a different runtime. At that time, Docker saw an opportunity in order to build a lower level runtime that could be common across both Docker and Kubernetes. So Containerd was increased in scope in order to match the needs of a container runtime for Kubernetes. In 2017, work had begun on Containerd's image backend. We created a new image backend that would be more stable than existing image backends. And we designed a plugin interface where we could make Containerd to be very extensible. And at that point, we also donated Containerd to CNCF. At that time, we also started a CRI implementation. Leo Lantau from Google and Mike Brown from IBM began working on that. By later 2017, Containerd 1.0 was released. The main feature for 1.0 was API stability. So that would allow for anyone to start integrating their projects on top of Containerd without worrying about Containerd breaking underneath them. CRI also went alpha at that time. In 2018, CRI reached beta. And at that point, we decided to bring CRI in as a built-in plugin inside of Containerd. And the 1.1 release of Containerd had CRI built in. And then just last month, we released Containerd 1.2. The biggest feature was we stabilized the container runtime shim API. So the runtime shim API allows for different runtimes such as Kata containers or gvisor to be integrated more easily in Containerd. And going forward, those implementations should be able to use on newer versions of Containerd as well. And then the other changes were primarily just focused on stability and making Containerd more extensible. So Containerd as a project, you see it as the need for it, as traditionally everyone's been using Docker, and over time there's been a lot of concern over the scope increases of Docker, as everyone wants a very stable base runtime. Docker has started to include higher level features such as Docker Swarm or networking stack, which is different than what may be used inside of Kubernetes. We also saw the desire to have a common runtime that can be used across many different platforms. So it can be used within Pouch, it can be used within Kubernetes. Pivotal Gardens also using Containerd today. As well as we're seeing cloud provider integrations. And Containerd is great for the cloud providers because it's not opinionated by design, and it can be easily extended into more specialized environments. Also, it's owned by CNCF and implements all the OCI standards. So the design of Containerd is mainly around having stable, loosely coupled components. Each of these components have clean interfaces and small scopes. Having a stable gRPC interface that will allow for upgrading Containerd without breaking clients. Having a design that's extensible so that you can use any runtime. You can design around your custom requirements. You can build your own plugins without having a set configuration structure. We have our smart client. So the smart client provides a higher level interface to the lower level components. So the overall architecture of Containerd ends up looking like this, whereas in the middle we have the Containerd daemon, which has all of those different components. At the top are the different container platforms that use Containerd, as well as the tooling that you may use on top of your container runtime. And at the very bottom we have the operating system, which is actually providing the container process and process isolation. So for the smart client, said it provides a higher level interface on top of all the low level or the more low level components. It's responsible for features such as push and pull. So the Containerd API itself doesn't have a function for polling, but the poll can be implemented directly on the client. And the client will provide access to some of these lower level components, such as the content store, the snapshotter, which are used to implement features such as poll. Also, the responsibility for creating like an OCI configuration is done on the client, rather than having the server responsible for making those decisions about what the runtime will look like. So the gRPC API is just exposing an API to the lower level components. It tends to mirror exactly what looks like underneath inside of Containerd. So we have a gRPC API for snapshots. We have an API for content, containers, tasks, events, and all of that. The metrics API is just a Prometheus API. So if you can use Prometheus to monitor Containerd, this API provides metrics for both the Containerd process itself and individual container level metrics. So if you want to get, for example, CPU usage for a specific container, you can get that through the Prometheus metrics. And it can be enabled through the Containerd configuration. We also have the Kubernetes support within Containerd, and that's done through the CRI plugin. CRI plugin just exposes a gRPC API, and the kubelet can be configured to talk directly to Containerd. So there's a few different areas in Containerd that have plugins. There's the CRI plugin, which is built in by default today. It's just a gRPC service plugin, meaning the plugin actually registers a gRPC service. So CRI is actually listening on the same exact service endpoint as the Containerd API. So we have snapshotter plugins. So we have some built-in ones. So overlay is the most common. We also have Btrfs and AUFS plugins. We also added in 1.2 the ability for you to configure a snapshotter plugin that is implemented over gRPC. And lastly, the runtime plugins. So as I mentioned in 1.2, we also added better support for the runtime shim API. So binaries basically implement the runtime shim API, and you can use any binary that's going to implement that. So whether that's Kata containers or gvisor. So this is mostly useful for VM runtimes. OCI runtimes are already supported. We also added a install tool to CTR. So this will allow for installing these binaries from a registry image very easily. So other points of extension, within the client, there are many areas where you can swap out, for example, the whole pull flow. You can just specify with service and provide a custom service when using the client. For actual plugins that run inside of Containerd, you can compile Containerd with your own plugins. They're all self-registered. If you just import your plugin, it will get used and it'll have direct access to all the internal services. So, as I said, CRI is one of those plugins.
Cool. What's that? Thanks, Dirk. So I'm an IBM programmer. Right? I've been around for a long time. I've written operating systems. You might have heard of OS/2 and Windows NT, the original stuff. I was actually working on DOS in the beginning. Okay, I swear I was on DOS. I sat next to the guy who wrote this program called Edlin, which was one of the earlier editors in DOS, and his name is Chris Beaton. And one time somebody asked me if I liked Edlin, and I said, "Oh, I hate that thing." And then the guy I was sitting next to said, "I wrote that." But so yeah, no, been around, and like you said, about maybe a year and a half ago, 2 years ago, they said, "Hey, Mike, you want to join this Containerd project? All you got to do is get a little demo together with Lantau, who's a great programmer, by the way." I thought I was good, but he's just popping out these pull requests faster than I can even think about. He's a good guy too. I like working with Lantau. I also like working with the Docker guys. Docker's been a great partner for IBM in open source. They want to push all these standards out, and people are using their products. They built the container model, Docker run. It's all been it's been a good run for us to help working with them and put it underneath IBM's cloud and all that kind of stuff. So we're excited about that relationship as well. What I'm going to show you here is the architecture that we're currently using. We have a kubelet. Does everybody know what a pod is? Pretty much. So in the Docker world, originally you would just run a container. Okay. Kubernetes decided to create this thing called pods. Okay. And they would actually hold a group of containers. Okay. The containers would need resources, and what they were doing is coming up with a model that actually replicates what you would do in the old days with applications, where you need to integrate with the database and you need to have your local storage and you need networking and all those things. So Kubernetes comes up with this thing called a YAML file that describes these stuff, right? And when kubelet, which is a server that's running on your host, when kubelet receives an instruction from the rest of Kubernetes that we need to create a pod, essentially we use this interface here, this gRPC interface, to receive that request, and then we take over. We build the pod. We bring the images down for the pod. We put it on disk, we mount the drives for you so that everything is ready for that pod, because the first instruction that Kubernetes says is, okay, container runtime, get ready. We're gonna run a pod on your node, you're gonna own this thing, go get all the files and tell us when you're finished. So kubelet will tell us to do that, and that's where this line is over here, going and building the stuff on disk to build the pod. And then what happens is they say, okay, run it. And what we do when we run a pod is we create a pause container. Okay, I apologize if I'm going too fast for the translators. we create this pause container. It's one of those containers over there. And you don't actually see it when you're using most of the tooling. But it is there, and it is there just to be the anchor for a namespace. For example, a network namespace that everybody's going to share in that pod, okay? So that the security is common across all the containers in the pod, okay? After that, those images are built using Containerd, thank you. But what we then do is we tell him we're finished, and he comes back and says, okay, now create the container in the pod that you said you could, and we do. We build the container, again, using Containerd services through the client API, which, by the way, this client API is amazing. I mean, he understood it. He didn't emphasize it enough. The client API is an API that any program can use, any program, and become its own container manager. Okay, with this client API that Mike Crosby put together, you can do some really cool stuff. If you're a programmer, I highly recommend you take a look at the GitHub Containerd repo, and you'll see some samples and some links that Michael Crosby has built that show you how to write these programs. Okay, if you get anything out of this talk, I think that's the most important thing, is that Containerd is there for you to use in any way you want. These guys love new users, of new clients of the code. They really do. Okay, and Garden, he mentioned, is one of those clients. We had something that was using our own runtime engine, and they wrote this client API, and I'm like, dude, man, I just moved everything over to the Containerd client with Lantile's help, of course, and it just works. And the guys that are in the UK, that were a guy named Jules, he's like, why do we? After about an hour of discussion, he was like, oh man, he's looking at the code. This client API is very cool. Okay, we'll switch. We'll go to the Containerd API. That's what sold it, by the way. So we're moving along. We're going to create a container now, and we create the shim first. The shim is a process that owns the container itself, so that when the container exits, we get the return code, and also so that we can create new standard I/O streams that go from down in the container land, where the instance of the process is running, all the way back up to Kubernetes, so that when you're running your client API, you can see the output of standard error and standard I/O. Okay, so it's, create the container, build the streams, attach the streams back to Kubernetes. We're not showing that line here, but there's another API server that's hosting the kubectl command line, and all the streams work. When the container exits, of course, then you get the return code, and we have to close everything out and delete the containers, that sort of stuff. Okay, runc is there because it's OCI. It's an OCI spec standard. We support in the Cry plugin. We support both the OCI image specification and the OCI runtime specification. Okay, very soon now, hopefully it'll be also a distribution specification that we can support. Okay, so if you're looking for standards, OCI is one of those types of standards bodies that we think are interesting. Okay, all right. All right. A little deeper on this one. We're showing CNI. I didn't mention on the prior chart. You're gonna love this. 100 lines of code. That's all it took to do all of our networking for this CRY implementation, because we give all the work to CNI, which is also a CNCF, incubator project. Right? No, it's been graduated. Yeah. So what we do is when we start up our pod, we tell CNI to please give us a namespace for this pod. They give us the namespace, and then later on when we run it, the operating system, it says, hey, you wanted for that namespace, you wanted us to call you for all the networking stuff. And so what happens at that point is CNI will load the plugins that have been configured for CNI. We support all of them. We don't, like I said, we don't care whichever one you want. In my demo, I'm using Flannel, but there's a lot of other networks out there. And the cool thing is, because CNI is there, if Weave wants to work, and they do work there, it just works. And that marries well with the Kubernetes model, which is another thing I wanted to mention. He talked about it a little bit, but for me, the biggest improvement in the Containerd model was to create something that was just the right size for Kubernetes. Okay, it doesn't have its own scheduling management. It doesn't have, you know, anything but what Kubernetes needs, pretty much. Although it can be extended, it was built just as a container, a Kubernetes, you know, runtime, and then a whole bunch of competitors to that, you know, decided to write their own clients on top, and then we had to deal with end clients, which is okay because they came up with this model for namespaces. So, and we'll talk about the APIs first. I'll talk about namespaces in a second, but just to brush over it, what Containerd does when you have multiple clients, and this is pretty cool, you can have multiple clients at the same time of Containerd that are actually running in the background. Okay, so if I'm running Docker, it's using Containerd, it's using its own namespace, a Containerd namespace. So it's not the type of namespace that you're used to seeing. It's literally just for Containerd to isolate the pods and the containers and resources, images, whatever's happening between Kubernetes and Docker or somebody else like Pouch. So if Pouch wants to have its own image files, you don't have to worry about a Kubernetes cluster, you know, using those images because Containerd is isolating the different clients that Containerd has, which is a good benefit because this means that you can have just one Containerd infrastructure running in the daemon on the host, servicing containers of all types for all clients. Okay? It's a pretty cool architecture. So the CRI APIs, this is the list. It's a lot of stuff. We support it all, okay? To talk about the CRI API, I mean, the Google guys did a good job on that too. They really did. Okay. Two tools that are of interest to developers. Okay. One is called CTR. We say it's unstable, but what's really meant there is that the APIs may change. The command line may change. So don't write a script that's expecting that the command line has never changed and not put it in your CI. Okay, so it's a nice tool and everybody uses it. If you get an issue, we'll fix it, right? So when we say unstable, it's not really unstable. We use it all the time. They just mean don't yell at us if we change the API, the command line. I'm sorry. Oh, simply container.
Yeah, just
it's an abbreviation, CTR of container. I'm sure it was Mike Crosby decided what to call it. Yeah. Yeah, Mike's a great guy. I don't know if you guys ever get a chance to meet Mike Crosby. Yeah, he's a very subtle, very quiet guy, but he knows his stuff. When he writes code, it's beautiful code. It really is. We like Michael Crosby. He's a pretty good guy. So crictl, if you look in GitHub, you're going to see a cry tools repository. The cry tools repository builds this client, and the purpose of this client is to be a command line interface for debugging programmers to be able to access any implementation of a CRI runtime. Okay, so you can use crictl to debug Containerd, to debug your pods, that sort of thing, or you could swap out Containerd and put something else there, and it would still work. For example, Kubernetes ships a thing called the Docker shim. As of about a year ago, the Docker shim that Kubernetes ships with began to run on CRI. So the very first, well-supported container runtime interface implementation, we call them integrations, was actually Docker shim. Okay, so you can swap out Docker shim for Containerd, with a simple configuration parameter. You say --extern, and you define the socket, that a Unix socket, that you're going to actually load these services on. Okay? All right. To get started, follow the links. I use kubeadm to boot up clusters. If you're a programmer, you might want to use local up cluster. They both, I think, work good for developers, for programmers doing analysis and just figuring things out. kubeadm versus kubeup cluster, I mean, they both run something on your laptop. It's pretty easy to set up a single node cluster using kubeadm. So we started using that. Demos. Okay, I think we have just enough time to switch out of this and see if I can't bring up my virtual box. Sorry, VMware. I actually have an account with VMware, but just out of habit, I'm used to using VirtualBox. Okay, let's see, switch to mirror mode. System preferences, mirror displays. I apologize if this ends up being an eye chart. I need my glasses too. Okay, so there's a bug there where you have to actually stretch the window to get it to repaint. I don't know. It's on the Mac, and I think there's a bug between. One of these days I'll try to push a PR for that. But anyways, different story. Okay, so can everybody pretty much see this screen? Yeah. Lights. Maybe, I don't know. No. I could turn the brightness up on here, but I don't think it's gonna. Funny. All right. All right, let me scroll back up, just so you don't think, I didn't think there'd be enough time to launch a cluster. So let me scroll up. Show you, okay, the sudo ps, there was nothing running before. So we've got kubelet running, okay? And we've got containerd running. Pretty much all you need. And then you run kubeadm init once you've got a container runtime configured for kubeadm. There's the init command. You'll notice the network sitter. That's pretty much the only option you need to do, or it'll try to, if you're running local, it'll try to use 192. It'll try to use localhost again, and localhost is already being used, so you get networking issues. Okay. After 10-15 minutes, because it has to pull the images down, that sort of thing. Then you should end up with it creates a bunch of certificates, because we're doing networking as well. And they're between these various kubelet servers, there's a lot of communication that goes on, and it is actually HTTPS. So even your STDIO I talked about when we do that stream, that has to be certified data. Okay, so that's what's going on here. All right. And then the last thing it tells you is like, okay, well, you've created your cluster. Now you need to go over to another computer and join into your cluster. But in this case, I'm just going to run one cluster. So all I need to do is tell Kubernetes that this master node that I just created on this computer is tainted. And what that means is it can also run nodes on it. I'm sorry, it can also run pods on it. Otherwise, usually the master node doesn't get the new pods. Okay. So it should be up by now. Let's see if I can. All right. So this is a sudo login. Over here, we've got a non-sudo login. And on the third one, surprise, we have Docker running. Now, why is that interesting? Remember the namespaces thing, right? This is great. This is great. Last weekend, before the conference, I'm sitting at home and I'm trying to do some stuff, and Ubuntu says, "Do you want to upgrade?" Sure. What could go wrong, right? Well, it turns out that Docker, announcement here, Docker actually shipped the container D with it in a non-isolated model. In other words, Docker shipped an 18-something version with Ubuntu on an automatic update that started using the container D that I was building and using for my demo. They changed, they did an update, and it worked. Okay, so I mean, by default there was a configuration change I had to make because Docker had a disagreement on something, but suffice to say, I was surprised and it just worked. And what it means now is that I can come over here and take a look at the namespaces, get a list, right? Yeah. Computer's running a little slow. So you'll notice in here the k8s.io namespace, that's Kubernetes pods, and the Moby one, that's the Docker pods. Or not pod, Docker containers. Because Docker doesn't need pods yet. We have to convince them, I think. I like pods. I don't know. Mostly because I come from a sessions world. I worked on WebSphere, middleware stacks, and we're used to sessions and running groups of applications, groups of processes, groups of containers, together. So we like that model. It fits well with us. How are we doing on time? 2 minutes. 2 minutes. Well, let's see. What can we show them here? Let's see. That's the Moby namespace. There's your container running in Docker. Okay. What's that? Oh yeah. Oh no. Oh man. This guy's trying to get me in trouble. One time I was doing a demo for Bill Gates. Yeah. And somebody reached over to my computer that I was demoing on, and he hit a couple of buttons I hadn't tested, and it locked up. It just locked up. And I had worked with Bill a lot on the NT stuff, and he says, "Mike, what happened?" And I said, "It was a proximity bit." He said, "Proximity bit? What do you mean?" "If Bill Gates is close to the computer, halt." And I whispered this to him, and he looks at me and says, "Mike, yeah, good technology." It's an old running joke, the proximity bit. Sorry. All right. So, well, anyways, the commands are cool. Oh, running what? Oh yeah. I'm sorry. Yeah, I've got all kinds of pods here. Let's see, pods. So the pods that are running here, I've got Nginx. I could probably curl to it. Let's see here. Oh, I don't remember the IP address, so sudo crictl and inspect. Oh, did I? Yeah. Inspect P. And see that 7 Baker Fox, we're going to go ahead and pull him down. You can use shortcuts. That's pretty cool. Let's pipe it to less. There's my IP address. I need that. And I want to curl to it, and I forgot what the IP was. These inspect APIs are pretty cool for programmers. We show a lot of information that wouldn't typically be available under kubectl. Lots of low-level stuff. What are all the mounts? That sort of everything's available. Pretty much anything you want to show. If you need anything else, open an issue. We'll add more stuff to it. Okay. Oh, that's right. We're gonna do a curl real quick. What do you mean show the pods? See, Nginx is running. What's that? Yeah, when we're out of time. All right. You want to close it? Oh,
Yeah.
Oh, so go back to the. Sorry, I got excited. Having way too much fun. Display preferences. Mirror displays off. Back to the presentation. All right. Pages, where'd it go? It should be right there. Oh. Yeah.
Yeah. So just want to say thank you everybody for joining, and try out Containerd. Come open up pull requests and issues if you have issues, or if you have any issue, like feel free to open up a. You have an issue right there. I see this guy has an issue.
Oh.
What's the difference between Containerd and the CRI?
The CRI-O project. We can talk afterwards about that. We don't have time to get into that. So.
It's another container runtime. It's different architecture.
Is there any roadmap to support SQL v2? Just what we want is the block IO SQL is short.
Yeah, so from Containerd's perspective, like once it's implemented in Run C, we'll support it. But we wouldn't implement that directly inside of Containerd. So you're talking about supporting push? So we have push in the client today. So we do have push support. What we don't have in Containerd is build support, but you can pull down an image from one registry and push to another. We do support push for private registries. If you have issues, then yeah, feel free to open one up. But push I'll say push right now is one that is we have support for it, but it's not as well tested because it's not in the critical path for like CRI, Containerd, or so BuildKit, for example, is using push pretty heavily. So if you have any issues with
I would think that would be the recommendation: is use BuildKit or Docker to push, and then when you're running on Kubernetes, Containerd, let it pull.
Yeah, so the next version of Docker will have push support, which will actually be using the Containerd code. And at that point, I think you can expect a lot of issues to be fixed that we haven't implemented, but haven't had a chance to really get all that working how we wanted to. Can it run in a VM or use? It can use Kata containers, yes.
So from my understanding, Containerd is like a container runtime and manage the lifecycle of container. So I'm wondering, like, in which situation you think it's fast that you also mentioned that Containerd provides this, let's say, APIs for the use. So in which situation that the program should bypass Docker and Kubernetes to talk to Containerd and with the containers for Containerd directly?
Well, for the most part, it's just tooling that we'd expect you'd want to do that. So like build tooling would be an example. Any sort of monitoring, we'd expect you'd want to use the Containerd API directly. for most container platforms, that's what we expect. But you can build kind of more advanced use cases, like the stuff that BuildKit's doing with the Containerd API is almost in ways we never expected it to be used. So there's a lot of stuff that can be done at that level, but when it just comes to running containers, you shouldn't need to use anything kind of special.
In your experience, does Kubernetes is stable enough for the production environment?
I'll defer to the Alibaba guys.
There might some problem of Docker. In some bad situation, runs instance is done, but the Docker daemon does not know. As a result, Kubernetes does not know it. So if Kubernetes may have some problem. And I know it's a hard question, but concern.
We run millions of test cases, and it's in production on IBM clouds and on GKE.
So I will say so what we do in Containerd is we do have like a constant stress test that's running 24/7 on the latest version of Containerd, where we try to run all these use cases and try to find some of these corner cases. The most part, like when Docker has an issue on top of Containerd, usually the bug is at the higher level, is at least what we found today, that it's not necessarily we haven't found any bugs at the Containerd level that are kind of critical from the Docker user perspective.
Sometimes it's the operating system, and we need a patch, right? So
yeah, blame the operating system or blame whoever's above us or below us, but yeah.
But I think from my perspective, that question is, we have 16 maintainers
Let's say thank
working
you,
almost full time on Containerd to make sure that if you're finding an issue, that we get it fixed as soon as possible, because we don't want any bad press. We don't want anybody not to like Containerd. So I fixed a PR over the weekend, right? Even though I'm coming here, we really want to make sure you guys are happy with it. But nothing's perfect.
Thank you, everybody.
Thank you, guys.
Thanks, man.